current that we talk about here is electric current. We are aware of actually water currents, wind currents and all. Water in motion is water current. The current that we talk about is electric current. It is the charge in motion. Charge in motion, which constitutes electric current. We basically look at different currents in our subjects. One current is drift current. Next current is displacement current. Very, very important for us when you go to waves. And the third current that we consider and is extremely important is diffusion current. Please check. Everywhere it is a current only. The current constituted by electric charge in motion is either drift current or diffusion current. Displacement current is to be understood through it. In fact, it is not the charge in motion. It is not the charge in motion. Once again, displacement is the current that we normally talk about in dielectrics. Drift current in conductors, and both drift and diffusion current in semiconductors. There is a big topic only in semiconductors in the syllabus itself, and extremely important topic to be understood: transport phenomena in semiconductors. When you talk about the transport phenomena in semiconductors, we should know that there are two types of transport of charges in semiconductors. One is drift, another is diffusion. And they should be in a position to discriminate between the real difference between this. Only when we talk about, remember the statements are very important here. Drift current through conductors that we normally talk about this, and we define the resistance of the conductor. Electrical resistance. In a given conductor, there is current. And that current is due to the motion of charge carriers, actual motion of charge carriers drifting because of the force experienced by the charge carriers in the conductor. And the force experienced by the charge carrier is definitely due to a force called as electromotive force, electric field intensity. How do you create electric field intensity inside a conductor? By creating the potential difference between its ends. Create the potential difference between the ends of a given conductor by using a voltage source. That creates, because there is potential difference between the ends of the conductor, there should be electric field intensity in between, inside the conductor. And that electric field intensity moves the electrons in a particular direction so that they move and constitute the current. If the electric field intensity is more, they move with greater velocity, because of which the current will be more. Please understand this. Only when we speak about this drift current constituted by the drifting electrons, drifting due to the field force, we talk about resistance of that particular conductor. It can be conductor or semiconductor also, that it is there. Drift current is there in both semiconductors and conductors. And whenever we talk about resistance, resistance is not the basic property of the material. Conductivity or resistivity, reciprocal of each other, right? Sigma. In the case of capacitor, I told you that, and we proved and discussed also that the capacitance of the capacitor depends upon the medium represented by the permittivity of the medium in that, and the dimensions. Different conducting media can be used to construct resistors, each having a specific sigma called as specific conductivity or conductivity, resistivity or specific resistance of the conductor. And the dimensions will determine the resistance of that particular conductor. Please remember, we will be talking about drift current, diffusion current. Definitely, these are the currents constituted by the real charges in motion. And for us to get into waves, wave equations, and wave propagation, we introduce a current called as displacement current. When we are talking about displacement current or diffusion current, please remember the resistance of the conductor will not come into picture. The conductivity will not determine this. The resistance comes into picture determined by the conductivity of the medium only when the current is drift. In this topic, we are worried about only the drift current. After Ampere's law, in the first Maxwell's equation, I will introduce the displacement current. When I go to semiconductors, I will introduce the diffusion current. The part of electromagnetics is only drift current. That is the current that we are talking about now. Always needs a conducting medium. The medium is conducting because it contains free charge carriers, which are not bound to a particular atom. Any conducting medium containing free charge carriers is taken as a conductor of some shape, some area of cross section, some length. So drift current is always, here it is conductor or semiconductor, it is drift current. Conductor or semiconductor. Listen. constituted by the charge in motion. The drifting charge. Drifting is moving. In any conductor. Next. Magnitude of the current. Is defined as the rate of flow of charge. Very wonderful thing it is. Through. Through is what? Always in the direction perpendicular to any cross section of the conductor. Can be conductor or semiconductor? Conductor. Any cross section, very, very important. Through any cross section of the conductor, irrespective of whether the conductor is of uniform cross section or non-uniform cross section. Magnitude of the current, if you want to see, we cannot measure it like this, but still we will say that. Even if you have a conductor of varying cross section, doesn't matter. Current through any cross section of the conductor will be same. This is actually because of the incompressible nature of the free charge inside the conductor. It's very important for us to know that. Next point. Irrespective of whether there is current through a conductor or not, total free charge inside a given conductor remains constant. It cannot change. Free charge required for the conduction. Total charge itself. I'm talking about only free charge here. Inside the conductor is fixed. I'm just giving the statements. Check whether you're comfortable or not. Because these are all the things that you know. Maybe diffusion and drift currents are, drift current as a term might not have come somewhere. They call it as conduction current. Drift current is conduction current. Other name of it. Drift is conduction current. I want to call it as drift only because they drift because of the field, in the presence of the field. Charge in motion in any conductor moving due to the field force. Field created by applying the potential difference between the ends of the conductor.